Good morning, students. This is a continuous session of the pointer part 2. Before going to this session, I recommend you must watch pointer part 1. So coming back to pointer part 2, here we discuss few important topics related to pointers. So first topic is pointers and functions. So just like any other data type, we can also pass pointer to a function. So question arise why we need to pass a pointer to a function. So if you remember, we discussed in topic functions call by value. So what call by value do is when we pass a variable by value to another function, and if we change anything in that variable, it does not reflect to the original copy, original value. So this is a program. If you remember that we discussed in that function topic, we have a two variables int a and b, and we are calling a function change value, and we are passing a and b into it. And what we are doing into it is we are storing this a into b into c into d variables, and we are incrementing it. So we are incrementing c to c plus 1 and d is equal to d plus 1. So when I print the value into function main, what it will do? It will not increment the value. It will only increment the value of these variables which are local to the function change value. So again recapping is the concept what we discuss in the function is, so in main you can see that the memory will be allocated for two variables a and b. A will have 10 and b will have 20. So when we call a function, what will happen? Another variables which will be local to the function c and d will be created, and we are incrementing the values into this c and d, so then it's become 11 and 21. So once we go back to the function main and try to print a and b, the value will remain as 10 and 20. So now the situation arises if we want to change a value, that is if we change the value in function, it should reflect in the main function. So how we'll do that? We do it by call by reference and using pointers. So let's first of all we create a program call by value. So I'm just recapping it call by value so that it's easy to understand call by reference. So here I am declaring two variables, int a is equal to 10, int b is equal to 20, and I'm printing those values printf slash and the value before function call percent d a. So let's copy this. So I'm printing the value of a and I'm printing a value of b. Then here I will call a function. I'm placing a space here. Then again I will after. So let's create a function. This is call by value. So function no change. Let's take a name. It's call by value. So it will take int comma. Let's create a function here. Void no change int c comma int d. Let's say c plus plus. and b plus plus. Now call this function non-change here and pass the value a and okay. So what I am doing is, once again, I have created two variables int a and b. Value of a is 10, value of b is 20. Then before calling a function, I am printing a value of a and b. And then I am a calling function change, no change. In this function, what I am doing is I am incrementing the value of c and d. When I pass a and b from this function, the value of a and d will be stored in c and d respectively. And these two variables will be local to this variable, this function. So after that, I am printing a value a and b. So let's run it. Okay, you can see that the value before the function a is 10, the value before the function is 20, and the value after the function is still 10 and face is 20. So now question is, if I want that, if I change a value here, it should reflect in this variables. So for doing this type of things, we use pointers, and the functionality is known as a call by reference. So what we do is we will pass pointers here instead of value, that is int pointer and int pointer. So let's do this same program by using call by value. So what change I need to do is I need to create int pointer here. And I will display here. I will need to do pointer. I need to do pointer here. I need to. You remember that if we want to access the value, we use star. Okay. So now here are now these are pointers. So pointers store what? Address. So I need to send the address rather than the value. So remember in first session how we send the address? We send the address using ampersand. Okay. So this is the program by call by value. So let's see what is the result. So you can see that the value a is initially is 10, value of b is 20, then after we call a function, it become 11 and it become 21. That is whatever I am changing here, it is reflecting into these two variables a and b. So let's understand the memory layout so you will have more clarity. So this is the memory layout of call by reference. So here you see that in main, two variables a and b will be created. Its address will be 100 and say and b address is 200 and value of a is 10 and value of b is 20. In change variable, another two variables will be created c and d. But in this case, c and d are pointer types. You can see that C or D are pointer type. So that means this C will store the address of A. So what is the address of A is 100. So C will have a 100 and this will D will store the address of B. So what is the address of B is 200. So now C and D stores 100 and 200. So when we come into this function, what we are doing is we are doing star c is equal to star c plus 1. That is, we are finding value at address. So when we do star c, c contain 100, star 100 will goes to which memory location? A, and then it increment 1, then it become 11. Do you understand that? Here I am doing is star c, star c. So c contain 100. So star of 100 means it is pointing to this location A and 11 will be incremented here. Similarly, start D, what will do is it goes to a 200 and it increment a 21 here. So this is how call by value is used. This is very important functionality of C language. So now let's see the difference between call by value and call by reference. This is very, very important even for the examination point of view. Call by value. The function is invoked by passing the parameters value. This is important. We always pass value. Here function is invoked by passing the parameter address. So you can see that here I am passing a address. If it is a call by value, it should be like this. So I am passing an address, then this two variables should be of pointer type. Second is the copy of the original variable is created and operation is done on the original copy, not on the original copy. So what call by value do is it create a copy of the original variable and we do operation on the copy, not on the original values. In this operation is done on the original value. So that's why whatever we made the changes will be reflected into the original values. So third part says same, any change made to the function argument does not reflect on the original value. Why? Because we always work on the copy. Here any change made to the function argument reflect on the original value of the variable. Why? Because here we always work on the original copy, original variable, not copy original one. So it's like a photostat copy. If any change made to the photostat, it does not reflect on the original copy. It is like a carbon copy. You might have seen that carbon copy. If we change anything, it automatically reflects on the other copies. So this is basically a difference between call by value and call by reference. Another point you need to make note of that is, if see in a function we can only return one value, but if there is any situation we want to return more than one values, so how we will do that? We use call by reference. Have you already seen that in this example? I have explained here I am changing two values and these two values are reflected back. So if I need to send 3, 4, 5, I will use another pointers. So if we want to return more than one value from a function, then we call by reference is a one of the way. So this is all about call by value and call by reference. So let's move to the next topic. Okay, next topic is pointers and arrays. Okay, so arrays are always handled using pointers. So what does it mean? It means that the name of the array always contains the starting address of an array. For example, if I have an address int a10 array name, so this array name will contain the starting address of an array. So if I print array, it will print the starting address of array. If I print address of starting address element, it will be the same one. Let's do it practical to understand more. So what I am trying to say is, in array, the array name always contains the starting address of an array. So let's create one array of element 3 and say its value is 1, 2, 3. Now, if I print the starting address of array, if I print the array name, what it will print? It will print the starting address of array. And if I print ampersand of this, it will also print the starting address of an array. This is same. If I print the first address of the array element, it will be same. So these three statements is same. That is, this also provide me the starting address of array. It will also provide me the starting address of array, and the first element also provide me the starting address of the array. So let's run it. So you can see that the result of all three statements are same. So what does it mean is arrays are always treated like a pointers, and the array name always shows the address, starting address of an array. So if I want to find the address of second element, how I will do that? I will say 1, I will say 2. So I hope you remember that ampersand always give the address. So what I am doing is I am doing ampersand array 1. That means give me the address of the second element, as the array index always start from 0. I am doing array at 2. It will give me the address of what? Which element? Third element. So I hope you remember that always arrays are always stored in a continuous memory location. So as the integer here in my system take 4 bytes, so 4 will be added here, 4 will be added here. Let's see. So you can see that the address of the second element is 72, that is difference of 4, and address of the third element is 76. Again, the difference is 4. So that proves that arrays are always stored in a continuous memory location, and the address of the array is always stored in the name of an array. So this is a graphical representation of the memory layout. So I have created one array of 3 elements, 100, 2, 102 and 104. So if I print array, only array, it will give me 100. If I have ampersand array, it will again print me 100. So same program we have discussed. Okay. The next topic is pointers and accessing elements of 1D array. If you remember that in an array topic we discussed that array elements are always accessed using index number. So if I have array int array 3 1 2 3, and if I want to access the second element, how I will do is array 1, right? So but how internally compiler do that? As we discussed that arrays are always treated as a pointer. So internally how it happens is, this is a very important thing to understand. I am accessing array 1. Internally it will be converted into this, that is array plus 1. 1 is the index number. Then this star, that is value at this. If the address of the array is 100, then it is replaced as 100 plus 1 star. Here 1 is the index number, it's not the numerical addition. If you have any doubts, go to the part 1 topic, how arrays are incremented, how pointers are incremented and decremented. So 1 means its index. So if integer take 2 bytes, so it become 102 and star. So at 102 is address and star means value at address. So 2 will be printed here. So like this 2 will be printed here. Similarly, array plus 1 can be written as 1 plus array. So this statement is also true. We can print the element like this and it become this. We can print like this. So there are 4 ways to print the elements of an array. First is array with index, which is the normal way we do. Second, as we discussed that array plus I star, it will also print the element. Then again mathematically it's same, I plus array star, it will again print the same element. Then we can also write array index then within the array. So these are the 4 ways of accessing the elements of an array. So let's look into that. So I already have this program. Let me print the value using all these foods. I say int I is equal to 0 for I is equal to 0, I less than 3, I plus plus. Let's first print in the normal way, what we are used to. Printf the value is percentage %d. So normal way array with index. Let me print it here. Printf the first way. Let's print that in second way. What is the second way is array is always treated like a pointer. So what I am doing is in a pointer I am adding an index here. Then it give me an address. Then I will say star give me the value at index. So this is the second way to do that. Let's print the third way. So same way, and the fourth one is I can say I array. This type of representation is very important from examination point of view or interview point of view. They do ask this. So let's run it. So there is a compilation error. Let me remove it. Okay, you can see that first way the value is 1, 2, 3. Second way again the value is 1, 2, 3. Third way again the value is 1, 2, 3. And the fourth way again the value is 1, 2, 3. So there are four ways to access the elements of 1D array. I hope it's clear to everyone. Now similarly in 2D arrays there are three ways to access the elements of an array. First is array 2 1, that is normal index. Second is array 2 plus 1, basically putting star, and third one is this is the way. So I will like you all to try all this option yourself for 2D arrays. Okay. The next topic is passing array to a function. We can pass the array to a function using pointers. As we know, the name of the array contains the starting address of an array. So we pass the array to function using pointers. Array always has a size associated with it. So we also pass the size of array into a function. So we are so the function need to know the number, the length of the array. That's why we pass the size into the function also. So this is general way of passing an array to a function is, so let us suppose I am having an integer array. So what I will do is int pointer, then I will say int size. Let's create a program to understand more about it. Okay, so I have one array there. Let me create a function void display. I need to pass a integer array, and array is treated always like a pointer, so I need to have an integer pointer. I will have a float pointer here if my array is of float type. If my array is of char type, then I will have a char pointer. So let's discuss the float pointer. Oh, integer pointer. And second, what I need to pass is size. So I say int size. So that's all. Now let's write a function int pointer p. So I am storing the address in p, and I am storing the size in size. So I need to display it. What I will do is, let's create a int I is equal to 0. Same way, I is equal to 0. I less than what? Size is stored in variable size. So I will use a size here. Then what I will do is I plus plus. Then I need to display the values. Printf percentage, the value is percentage d. Now the array address is stored in pointer p. So I will use p, and I will use the index here. Right. So now I need to call it display function. Display function, we need to pass the address of an array. As we discussed, the address of the array, name contain the address of array. So I can say simply this. This is the one way. Again, let's first just run it. Then I will explain the another one. Okay. It's not it's semicolon here. So you can see that it displays the value 1, 2, 3. So this array is passed to a function. So again, I am stressing it. When we pass array to a function, we pass it using pointers. So here I am sending a address of an array. So you might say that I am not using ampersand. The reason is that the name of the array contains the address. So it's passing an address. So you can, if you can also do like this. There is no issues on that. Because here I am explicitly sending the starting address of an array. Same answer. Index 0 is the starting address of an array. You can also send like this. It's not a sending. Here we are sending a starting address because element 0 is the address is same as the starting address of an array. So it will also work. So there are three ways. Let me all copy all three together. First is this one. Second is this one. And third is addressing it. Let's run it. So you can say that all three methods give me the same results. So this is all about array, passing an array to a functions. So always remember that arrays are treated like a pointers. So whenever we need to pass array to a function, we need to pass the point address of an array and the size of an array. So let's move to the next. Okay, next topic is double pointers. So in the first part, we have discussed the single pointers. So now we will discuss the double pointers. Pointers, as we discussed, contain the address of another variable. If you remember that another variable can be pointer itself. So we have a pointer which contain the address of another pointer. This is known as a double pointer. So what does it mean is I am having a pointer which will contain the address of another variable which is also of a pointer type. So while declaring a double pointer, what we do is we put two asterisk before the name. For example, int star star p. What does it mean? Pay attention here. It means that p is a pointer which contains the address of another pointer which point to the integer value. Why integer value? Because it's written as a integer pointer. So let's discuss the memory layout. You will have more clarity on this. So this memory layout is somewhat similar to single pointer which we discussed in the first part. So so if I create a variable int a is equal to 10, how memory will be allocated? A variable will be created in memory which will have value as 10 and address, let's say, is 500. If I say int pointer p, how memory will be allocated? A p variable will be allocated in memory which will have a address, say, 1000. Now if I say p is equal to ampersand a, what I am doing is I am storing of the address of a into p. So it will be like that. This is up to now is the like a single pointer. Now if I do this, so what I am doing is I am creating a variable p1 which is a double pointer and it will store the address of a p. So what will the memory look like? Memory will look like this. I will have a variable which has a value 10. Its address 500 will be stored in pointer p. Now pointer p has an address 1000 and its value will be stored in p1. So this p1 is a double pointer because it is storing an address of another variable which is of a pointer type. So this is all about the double pointers. Let's do one question on that so we have more clarity. Okay. This is the same as the previous one. What I am doing is I am creating a variable int a is equal to 10 and I have created another one pointer int pointer p is in it I am storing the address of a, then I am storing int double pointer address of p. A memory layout as the previous. So now if I say ampersand a, if you remember what ampersand do, it gives the address. So what I am doing here is I am getting the address of printing the address of a. So address of a is 500. So it will print a 500. Next what I am doing is ampersand p. Again ampersand to what? Address. So here what I am doing is I am printing the address of p. Address of p is 1000. So answer should be 1000. In third what I am doing ampersand p1. Ampersand p1 basically what it will do? It will give the address of p1 which is 2000. So this will be the output. Now next one. What I am doing is I am printing a variable a. So variable a contains what? I am not using ampersand, I am not using star. So it will only print the value of a. Here the value of a is 10, so 10 will be printed. Next I am printing the value of p. I am just printing p. So what p store is 500. So answer should be 500 because p here stores the address of a which is 500. So here 500 will be printed. And then I am printing p1. Here p1 stores what? Address of p which is 1000. So here 1000 will be printed. Now the third one is very important. Here what I am doing is ampersand value at p. What I am doing is asterisk p. So what first it will do? It will pick p. What is p store? 500. So it will stay ampersand value at 500. So value at 500 is what is 10. So it will print a 10. Again I am explaining it. First it will be P. So what is there in P? P is 500. So this star gives what? Value at address. So value at address 500 is 10. So 10 will be printed. Second one I am doing is P1 star. So P1 contains what? 1000. And I am saying star. So that means value at 1000. What is the value of 1000 is 500. So 500 will be printed. Now look into this. I am doing star P1. So how it will work? It will first pick P1. P1 stores what? 1000. So it will do star 1000. Now first star 1000 give me value 500. Then it become star 500. Then star 500 will goes here. Then it will print 10. So this should be the output. I have a program for the same. Let me run that. Same way I am doing this. Ampersand ampersand A. Let's run it. So first I am printing address of A. Address of A is something like that is 580. Then I am printing the address of P. Address of P is 568. I am only pronouncing the last three digits. Then the address of P1 is 560. Then what I am doing is I am printing the value of A. A contains what? 10. So answer is 10. Then I am printing P. Here P contains what? Address of A. Address of A is, you can see, is 580. So it's printing a 580 here. Next what I am doing is I am printing P1. P1 contains what? Address of P. So here address of P will be printed at 568. You can see this is the address of P, 568. Then I am doing a star P. Star P means value at point P. P contains what? Address of A, that is 580. Then value at 580 is value of A. So 10 will be printed. Similar way address of A will be printed here. And last you can see that 10 will be printed. I hope it is clear to everyone. So I hope you have understand the concept. Please do practice and also subscribe the channel for more updates. Thank you.